Hey everyone, and welcome to today's deep dive. We're going to be looking at something that might sound a little intimidating at first, parts per million, or PPM.
It sounds very sciencey.
Yeah, but stick with us. We're going to be using this great article from Atlas Scientific to help us break it all down. And, it might seem technical, but honestly, PPM is super useful in everyday life. I mean, we're talking about everything from making sure our drinking water is safe to understanding, car emissions.
It's true.
And you know what? I was actually reading the article and I learned that PPM is even used to measure defects in manufacturing. And it's way more demanding than you might think.
Oh, yeah, for sure.
So I guess the big question is, what is PPM and how does it actually work? And why do we even need such a tiny unit of measurement in the first place? What's the deal with that?
Yeah, I agree. PPM can seem a little abstract, but it all boils down to understanding proportions.
Okay.
It's kind of like trying to find a single grain of sand on an entire beach.
Ooh, that's a good analogy.
You know what I mean?
Yeah. So let's start with the basics. The article from Atlas Scientific defines PPM as, and I'm quoting here, a unit typically used to express the concentration of a substance in a solution or mixture. Okay. Can you maybe break that down for us a little bit? What does that actually mean in, regular language?
Sure. Well, think of it like this. Imagine you've got a giant cake.
Okay. I like where this is going.
And you just add a tiny pinch of salt. Now, that pinch of salt is super small compared to the whole cake.
Right.
But it's still there, and we can actually measure its presence using PPM.
So PPM is like a way to measure those tiny ingredients, even if they're almost invisible.
Yeah, exactly. It helps us quantify those tiny, tiny amounts and understand how they affect the bigger picture.
Okay. I'm starting to get it. Now, the article also mentioned that PPM is used in a bunch of different industries: water treatment, pharmaceuticals, even making cars. So I'm curious, how did scientists even measure those teeny tiny concentrations before we had PPM? What did they do?
That's a really good question. Early scientists, they relied on simpler methods like basic ratios and percentages.
Makes sense.
But as science got more advanced, we needed more precise measurements. You know what I mean? Those old methods just weren't cutting it anymore.
Yeah, I can imagine trying to measure something potentially harmful in our drinking water using just percentages. That just doesn't seem accurate enough, does it?
Exactly. Think about it. If we're dealing with something that could be dangerous even in super small amounts, we need a way to measure it that's really, really sensitive. That's where PPM comes in. It gives us that extra level of precision.
Okay, so PPM is all about taking those tiny amounts seriously, especially when it comes to our health and safety.
Right.
Got it. Now, let's say, hypothetically, I have a liter of water, and let's say there are 0.2 grams of salt dissolved in it. That sounds like practically nothing to me.
Right. And to your taste buds, it probably would be barely noticeable. But if we translate that into PPM, it's actually 200 ppm of salt in that water.
Yeah.
And depending on what we're using that water for, 200 ppm could be a lot.
So even though 0.2 grams seems tiny,
Mm-hmm.
when you put it in terms of PPM, it suddenly becomes much more, real.
Real, yeah.
Tangible or something.
Yeah.
So how do we actually go about calculating PPM? The article mentioned two ways: using volume and using mass.
Okay, so let's start with volume. Imagine we're measuring CO2 levels in the air.
Okay.
To get the ppm, we divide the volume of CO2 by the total volume of air and then multiply by 1,000,000.
Okay. So if we had, say, 0.0004 cubic meters of CO2 in a 1 cubic meter sample of air, what would the ppm be then?
All right, so you would divide 0.0004 by 1, which is still 0.00004, and then multiply that by 1,000,000. That gives you 400 ppm of CO2.
Got it. So it's all about figuring out the proportion of that tiny ingredient within the larger whole. Now, what about calculating ppm using mass? How's that different?
It's really similar. Remember that saltwater example?
Yeah.
So we know the mass of the salt, 0.2 grams, and the mass of the water, which is 1 kilogram or 1 liter. We just divide the mass of the salt by the mass of the water, and then, just like before, multiply by 1,000,000 to get the ppm.
Okay, so in that case, we divide 0.2 grams by 1,000 grams, because a kilogram is 1,000 grams.
Right?
And then multiply by 1,000,000, and that gives us that same 200 ppm we got before.
Huh. It's interesting how both methods lead to the same answer.
Exactly.
And I'm glad the article also mentioned online PPM calculators. Those seem super helpful.
Oh, for sure. They're lifesavers. They can make the calculations way faster and easier, but it's still important to understand what those numbers actually mean.
Totally. Understanding the why behind the what. Right.
Exactly.
The article also pointed out that ppm in water is the same as milligrams per liter, or mgl, which I've seen on water quality reports. I never realized that was ppm.
Yeah, you've probably seen it a bunch of times without even realizing it. It's a good example of how PPM can be expressed in different ways, but the idea behind it is the same. And speaking of expressing things differently,
Wow.
what about converting percentages to PPM? I remember the article had a pretty simple formula for that.
Oh, yeah, it's super easy. To convert a percentage to ppm, you just multiply the percentage by 10,000.
Uh,
So, for instance, if a product label says it has 0.05% of a certain ingredient, that's the same as 500 ppm.
That's actually really helpful to know, especially when you think about defect rates, which are often given as percentages.
Yeah, exactly. Being able to quickly convert between percentages and ppm can be really useful.
So now that we have a good grasp of what PPM is and how to calculate it, should we maybe dive into some of its real-world uses?
Let's do it.
I'm excited to see how this tiny unit of measurement plays such a big role in so many different areas.
Me too. It's pretty fascinating. Let's kick things off with something we all need. Good old H2O. You know, water treatment plants use ppm to super carefully monitor the levels of things like chlorine and fluoride in our drinking water.
Yeah, it's like they have to find the right balance, right?
Oh.
Enough chlorine to kill all the bad bacteria, but not too much that it makes the water taste weird or, becomes a health risk.
Then it's the same deal with fluoride.
Okay.
The right ppm of fluoride is actually good for your teeth,
Yeah.
but too much, not so much. ppm helps them fine-tune it. It's not just chucking stuff in. It's about adding it in very specific, measured amounts.
Right, like that saying, the dose makes the poison,
Right.
Even good stuff can turn bad if we get too much of it.
Yeah.
I guess PPM helps us find that sweet spot.
Totally. That's a great way to put it. And this whole precision thing isn't just for stuff we add to water, but also for things we want to get rid of.
Oh, you mean like contaminants?
Exactly. Things like heavy metals, lead or mercury. Those can be super harmful even in tiny amounts. ppm lets us detect and measure them with the sensitivity we need to make sure the public's safe. Did you know that just 5 ppm of lead in drinking water is enough to be harmful to kids' development?
Wow, seriously? I
Yeah.
had no idea it was that sensitive. So those water quality reports we see, it's not just random numbers, huh?
Mhm.
It's actually showing us all the work they do to keep our water safe.
For sure. ppm is like a behind-the-scenes hero in the water treatment world.
I like it.
And it's not just drinking water either.
Oh, right. The article mentioned aquaculture too, right? They use PPM to measure dissolved oxygen in fish tanks.
Yep, exactly. They need to make sure there's enough oxygen in those tanks for the fish and other aquatic life to, thrive.
So PPM is helping keep those underwater ecosystems healthy too.
Exactly.
Wow. It's really amazing how PPM can be used in both natural and man-made environments.
It is.
So what about pharmaceuticals? Precision's got to be super important when it comes to medication, right?
Oh, absolutely. Think about it. The active ingredients in your meds, they need to be there in very specific amounts to actually work.
Yeah.
ppm makes sure those medications are formulated with the right concentration of each ingredient so they're safe and effective.
Wow. Makes you realize how much we depend on this PPM thing, even if we don't see it. It's like a silent guardian making sure our medicines are made correctly.
It really is. And it's not just about the active ingredients either. ppm also plays a huge role in spotting and controlling impurities in medications.
Oh, that's interesting. I hadn't thought about that. What kind of impurities are we talking about, and how does PPM help with that?
Well, impurities can be leftover stuff from the manufacturing process.
Oh, okay.
Or maybe tiny amounts of something else that accidentally got in. Even those tiny bits of impurities can cause problems,
Oh, wow.
like bad reactions, or they could make the medicine less effective.
So PPM's like a quality control superhero, making sure our medications are as pure as possible.
Exactly. It adds that extra layer of quality control so we can be sure the medications we're taking are safe and do what they're supposed to do. And in a field like pharmaceuticals, where even tiny changes can have big consequences, that kind of attention to detail is critical.
Seriously, it's mind-blowing when you think about it. These super tiny, almost invisible amounts can have such a big impact on us. The article also mentioned the food and beverage industry, which makes me wonder, how does PPM fit in there?
Oh, PPM's all over the food and beverage world.
Really?
Think about all the ingredients in everything we eat and drink. Some are added in on purpose, like to make things taste better or last longer. Some are there unintentionally, like maybe tiny amounts of pesticides on produce.
So PPM helps us figure out what's in our food.
Yeah.
Good stuff and the maybe not so good stuff.
Exactly. For manufacturers, it's about making sure things like additives and preservatives stay within safe limits and checking for contaminants so that, the food we're eating meets those quality and safety standards.
Right.
It's kind of wild. For instance, PPM might be used to track how much caffeine is in your soda or the vitamins and minerals in your cereal.
It's like a secret code that unlocks what's really in our food.
I like that.
Now, what about environmental monitoring? We talked about that earlier.
Oh, PPM is essential for that too. Like when we hear about air pollution levels, they're often measured in PPM.
Right.
Things like carbon monoxide, ozone, or particulate matter, stuff that can really affect our health and the planet.
Oh, right. And the article mentioned CO2 levels in the atmosphere, too.
Mm-hmm.
Scientists track those using PPM, don't they?
Absolutely. Carbon dioxide is a big player in climate change. So by keeping tabs on CO2 levels and PPM, we can see how we humans are impacting the atmosphere over time.
So PPM is helping us keep an eye on the health of the planet, too. It's incredible how something that sounds so technical can be so important for so many things.
It is, isn't it? It all comes down to the power of precise measurement. PPM helps us understand these tiny but crucial differences that affect everything, from the safety of our water to the quality of our food to the health of our planet.
Absolutely. And we can't forget about cars.
Oh, yeah.
The automotive industry uses PPM in a few different ways, too, right?
For sure. So first, there's measuring those vehicle emissions. Got to make sure they meet those environmental regulations.
Right.
But PPM is also super important in the manufacturing process itself.
Right. The article said the automotive industry actually aims for just 25 defective parts per million. That sounds almost impossible.
I know, right? It shows how much manufacturing processes and quality control have advanced.
Yeah.
Hitting such low PPM rates just wouldn't be possible without, seriously sophisticated tech and a really deep understanding of statistics.
So how do they even start to tackle that? It can't just be about inspecting parts at the very end, right?
No, you're right. It's about building quality into every single step. From the design phase to sourcing materials to production and assembly, it's a holistic approach. Got to have meticulous planning and constant vigilance.
So it's about preventing defects, not just reacting to them.
Exactly. It's being proactive, lots of testing, constant monitoring, and a real culture of quality throughout the company.
It really makes you see building a car in a whole new light. Behind all the sleek design and perfect finish, there's this whole world of intricate processes and checks, all driven by getting those PPM rates down super low.
It's a great point. It reminds us that quality isn't just how something looks. It's about safety, reliability, and performance. And let's face it, sometimes it's literally about life or death. Think about medical devices or airplanes. Even a tiny flaw can be disastrous.
That's a sobering thought. It really highlights the responsibility manufacturers have to get it right.
Absolutely. And that's where PPM steps in. It's a powerful tool for measuring and improving quality. It's not just some number. It reflects all the dedication, precision, and commitment to getting things right that goes into making the products we depend on.
So as consumers, how can we support that? I mean, aside from just choosing brands and products with good reputations.
That's a good question. I think being informed is key.
Okay.
Pay attention to labels, do some research on how things are made, ask questions about quality standards. The more we as consumers demand quality, the more companies will have to step up their game.
And that brings us right back to PPM. Now that we get it, we can start to see it as a sign of quality.
Exactly. It's not just a technical term anymore. It's a clue about the care and precision that goes into, making a product or keeping our environment safe.
So next time we see PPM on a label or a report, we should really think about the story behind it.
I think so. It represents a ton of scientific knowledge, advancements in technology, and human ingenuity all working together to make our lives safer, healthier, and better overall.
It's amazing how PPM has taken us on this journey, from the tiniest parts of a car to the Earth's atmosphere.
Yeah, it shows you how connected everything is. Even the smallest things can make a huge difference.
So as we wrap up our PPM deep dive, let's recap for our listeners. We started off defining PPM as a way to express those incredibly small concentrations, like finding a needle in a haystack.
Right. Remember that grain of sand on the beach analogy?
Right.
PPM helps us put a number on those tiny, tiny amounts so we can understand what they mean in the bigger picture.
And we talked about how to calculate it. dividing the amount of a specific thing by the total amount of the mixture and then multiplying by 1,000,000. We can use either volume or mass to do that, right?
Yep, depending on what we're measuring. And those calculations can sound kind of complicated, but there are tools and calculators online that make it super easy. The important thing is to understand what those PPM numbers actually tell us.
Right. And then we explored how PPM is used in all these different industries.
Yeah.
Water treatment, pharmaceuticals, food production, environmental monitoring. PPM is everywhere. It keeps things safe, effective, and within those limits.
Yeah, it's about keeping that balance, making sure the good stuff is there in the right amounts, the bad stuff's kept in check, and everything's being watched to make sure it's safe and high quality.
And we can't forget about the incredible precision they need in manufacturing. That automotive industry goal of having only 25 defective parts per million blew my mind.
I know, right? It requires a whole different approach to manufacturing. They're not just finding defects, they're trying to stop them from happening in the first place. Rigorous testing, constant monitoring, really understanding every single step in the process.
It's impressive what they can accomplish when quality and precision are at the forefront.
Yeah.
So for our listeners out there, what's the main message you want them to walk away with after this PPM deep dive?
I think this. Even though PPM deals with these super tiny amounts, it has a huge impact on all our lives. It's like a silent guardian, making sure our products, our environment, and even ourselves are safe, healthy, and in good shape.
Well said. Now that we know what PPM is all about, we can see it everywhere. It's on labels, it's in reports, and it reminds us that even the tiniest things can make a huge difference. Thanks for joining us on this fascinating journey into the world of PPM. Keep exploring and stay curious, everyone.